Okay, today we looked at some of the exponent rules. And so when you get ready to do some of module 5, you need to make sure you kind of use some of these rules. The first one, when you are multiplying like bases, A's, you add the exponents. So A to the n plus 1 would make it a little bit more simple. With this one right here, we have a power raised to a power. So if you have a power raised to a power, you multiply the exponents. You end up with a to the n times m. On this next one, we have a product on the inside. The bases are different, and both of them are raised to exponents, raised to another exponent. So if you have a product raised to an exponent, you multiply each exponent of the bases by the x on the outside. So we end up with a raised to the n times x, b raised to the m times x. And this is the one that we worked on last week. If I have a raised to a negative exponent, put a 1 under it, flip it. We want the reciprocal. And now my exponent on the a is positive. On the next ones, we have a quotient raised to a negative exponent. So the rule says you take the bases on the inside, flip them. So notice that the a is now my denominator, the b is my numerator, and now my exponent is positive. Now this is the quotient rule. When dividing, that's what that fraction bar is, like bases, subtract exponents. So we end up with a base of still a, and now we're going to take the numerator's exponent, which is m, and subtract the denominator's exponent, which is n. So an example with that rule right here, I have 4 raised to the 5th divided by 4 raised to the 2nd. So if the bases are the same, you keep it, that's 4, and you subtract your exponents. 5 minus 2, which is 3. Now we're going to multiply 4 times 4 times 4, which gives me 64. Another rule is a quotient raised to a power. And notice the bases are different, and here are the exponents. So what that rule says is that when you have a quotient, that's division, and those two bases have exponents raised to another exponent, you multiply the x times the n and the x times the m, and then you end up with a to the n times x over b raised to the m times x. So if I put all of this together, here's a problem dealing with the quotient. I have x squared y to the 5th divided by x, and that's a 1 to the 1st, y to the 2nd. So take the same bases and write them as a fraction. Same bases, write it as a fraction. So when dividing like bases, keep the base, subtract the exponents. 2 minus 1 gives me 1, and I really don't need to put that 1 there. Do the same thing with the base of a y. Bases are the same, keep it, subtract the exponents. 5 minus 2 gives me 3. So my answer would end up to be x, y cubed. So in module 5, you're going to be using those rules. So you need to make sure you know how they work. So let's say, for instance, if I have 2a squared times 3a to the 5th, and I want to write this using one exponent. So when we're working out this type of problem, we have 2a squared times 3a to the fifth. Remember, multiplication is commutative and it's associative. So you're going to rewrite this by multiplying the numbers together. 2 times 3. And then I have like bases. Put those together. A to the second times a to the fifth. So I'm going to multiply 2 times 3. That gives me 6. When multiplying like bases, keep the base, add the exponents. 2 plus 5 gives me 7. So I end up with 6a to the 7th power. All right, look at another one. Let's say I have 4, let's say negative 4, x cubed, y to the 5th. I want to multiply that by 5x, y to the 9th. I'm going to put them in parentheses. So I can rearrange this because all of this is multiplication. Rearrange it, multiply the numbers. Like basis in its own parentheses, x cubed times x. And since that's 1x, that's going to be a 1 as my exponent. And then my y's, like basis inside parentheses. Multiply the numbers. Negative 4 times 5 is negative 20. When multiplying like bases, keep the base, add the exponents. 3 plus 1 gives me 4. When multiplying like bases, keep it, add the exponents. 5 plus 9 is 14. So my final answer is negative 20, x to the 4th, y to the 14th. Now sometimes your exponents could be negative. So if I have 3a to the 5th, x to the 3rd, and I want to multiply that by 6, a to the negative 1, x to the negative 2. It's more than one way I can do this problem. Now, if you look at this problem, we have this over here to have some negative exponents. You really don't have to change them to positive exponents. You can use one of those rules in conjunction with one of the first one. So let's rearrange it. The 3 and the 6 are numbers. I can multiply those together. So I'm just going to take those and rearrange it. 3 times 6. The A's, I'm going to put them in their own parentheses, like bases. And the X's, I'm going to put them in their own parentheses, like bases. So it would be easier to use the, when multiplying like bases, add the exponents with this one. Multiply the numbers. 3 times 6 gives me 18. When multiplying like bases, keep the base. Add the exponents. 5 plus negative 1 is 4. When multiplying like bases, keep the base. Add the exponents. 3 plus negative 2 is 1. So I can rewrite this as 18a to the 4th x. So you're just simplifying it. The last type of problem we dealt with is the quotient rule. All right, so let's say, for instance, if I have 4x to the 5th, y to the 15th over 2x to the 3rd, y to the 2nd. Put the numbers as a fraction by itself. Like bases by themselves. Divide the numbers if you can, or simplify it. 4 divided by 2 is 2. When dividing like bases, keep the base. Subtract the exponents. 5 minus 3 is 2. When dividing like bases, keep the base. Subtract the exponents. 15 minus 2 is 13. And I'm done. So keep working on your exponent rules and using them. Remember, there's more than one way. I could have done this problem up here. There's more than one way I could do this one. But we want to look for the most simplest way to simplify expressions like this in algebra. I will see you on Wednesday. Please continue to work in Alex and have a good night.